Okie dokie. In this problem, they say all of the graphs appear to be straight lines. Using 3 points, which one could actually represent a linear function? So this is kind of testing the idea that linear functions have constant slopes or constant rates of change the entire time. So the way we will go about checking which of these graphs has a constant slope is with our 3 points here. We will find the slope between points 1 and 2 first. Then we'll find the slope between points 2 and 3. Then we'll check if those two slopes are equal to one another. Whichever graph has those two slopes equal to one another will be the graph with the constant slope, and then it'll be our answer, right? Okay, so to find the slope between 2 points, we do rise over run, or if you wanted to, you could identify the ordered pairs at each of these points, like 6 comma 28 and then 8 comma 36, and then do y2 minus y1 over or divided by x2 minus x1 to find the slope like that. I am not going to do that. That just takes way too long in my opinion. So I'm just going to do a little visual rise over run situation. So from this point to this point, we are rising from 28 to 36. That is a rise of 8. So you have to know the difference between those. So it couldn't hurt to use a calculator if need be. 36 minus 28 gives us that 8, and we are running from 6 to 8. So 2. So 8 over 2 is our first slope. If you want, you can simplify that to 4. 8 divided by 2 is 4. Now, the second point to the third point has a rise from 36 to 40. That is a rise of 4. And then we have a run from 8 to 9. That is a run of 1. And it just so happens that 4 over 1 is also equal to 4. So it turns out that the slope between points 1 and 2 equals the slope between points 2 and 3. So this will actually be our answer. I'll just go ahead and show why one of the other graphs is not our answer, and then I'll go on to one more example of this problem. All right. This one, points 1 and 2, rise over run. Rise is 3 from 7 to 10, and run is 2 from 6 to 8. So rise over run is 3 over 2. Second and third points. Rise from 10 to 12 of 2, and a run of 1 from 8 to 9. So 2 over 1. So it turns out that 3 over 2 is 1.5, and 2 over 1 is just 2. So 1.5 does not equal 2, or 3/2 does not equal 2 over 1. So that's why this graph does not represent a linear function. Okay, and so that same thing should happen for all these other ones. We would get two slopes that are not equal to one another. Okay, let's do one more example. Let's get going. So first point to second point. It's a rise of 10 from 27 to 37 and a run of 2. So 10 over 2, or 5, is our first slope. Second and third points. Rise of 37 to 43. That's a rise of 6. And a run from 8 to 9 of 1. So does 6 over 1 equal 5? No, it does not. Let's eliminate that. Go on to B. First points to the second points. Rise of 3 from 7 to 10. So 3 over. And then it seems to always be like a run of 2 and then a run of 1 from 6 to 8 and then 8 to 9. So that's kind of a nice pattern. So 3 over 2 for the first one. And then a rise over run of 10 to 12 is 2. And then a run of 8 to 9, which is 1. A run of 1. So does 3/2 equal 2 over 1? It does not. So we eliminate that. That was a little rough. I'll try to redeem it here. First 2 points has a rise of 6 from 21 to 27. So rise of 6. Run of 2 from 6 to 8. So 6 over 2 is equal to 3. Second and third points. Rise of 3. Run of 1. Okay, so 3 over 1. Does 3 over 1 equal 3? Yes, it does. So C is our answer here, and we can, say that with confidence, assuming that D would lead to, another one of these not equal situations. Hope that's clear enough. That's all there is to it, baby. If you have any questions, you just let me know.